Okay. Good evening, everyone. Thanks for giving me time to present my work. I would like to present that how affective approaching sounds modulate the whole body action preparation within the peripersonal space. Considering, sorry, okay. Considering the sounds when a bird sings, someone claps, or a car passes, all these sounds, based on their context, they imply to do an action sometimes. Considering the context, we can point on the distance of the sound and the emotion of the sound that it's implying. Considering the sound distance, a multisensory representation of neurons in the brain have found, which is going to increase the activation of the brain when auditory external stimuli falls into peripersonal space. What is peripersonal space is the reachable distance, simply to define. Like this case, when a sound falls into the peripersonal space, the brain activity is higher compared to this case when the sound stays outside of the peripersonal space, which the brain activity is lower. Considering the emotional content of the sound, also the research shown different modulation in actions. Consider emotion has two main dimensions, which is balance, which is positivity and negativity, and arousal, which is the activity of the emotion. It is found that we react faster to highly arousing sounds, and also we react more prone to the negative sounds in terms of increasing the survival rate. In this study, we would like to investigate how different affective approaching sounds, stopping at different distances within peripersonal space, modulate the action preparation. In this study, we considered a whole body action, which is a stepping. So in this experiment, simply the participants, they were listening to the sounds which they were approaching from either left or right side. And in two different experimental sessions, they were asked to step toward or step away from the sound. We did this step toward and away from sound in order to check the motivational direction and its effect in the movement facilitation, its effect. Considering the sounds that we used three main emotions: positive, negative, neutral. We considered 5 different sounds per emotion. So we had 15 sounds in the end. We considered 2 stopping distance for approaching sounds, 1 close, which is within peripersonal space, and 1 far, which is outside of it. And we considered 2 repetition for each trial, which ended up to 120 trials for each session. In order to measure the action preparation, we considered the premotor reaction time, which is considered the time between offset of external stimuli and the postural and muscular activities prior to the visible movement. So considering postural and muscular activities, we measured the force changes under each foot prior to movement using force plate, which we named it force premotor reaction time, FPRT, and we considered the postural muscles electromyography activity, which we called it EPRT, electromyography premotor reaction time. Also, we did subjective evaluation of emotion, which I didn't bring the result here in order to, because of the limitation of the time. The statistical design that we used, it was repeated measure ANOVA, considering 2 actions, which was toward and away, 3 emotions, and 2 distances. The results showed that the force premotor reaction time was faster for neutral sounds in far distance compared to all the other 2. Also, the force premotor reaction time was shorter to negative sounds compared to positive one. Interestingly, considering the interaction of distance and the sound type, we found that in the far distance, the reactions to negative sound was faster compared to positive ones, but not in close distance. The results for the postural muscle showed the same facilitation in action as force premotor reaction time, so I don't repeat it again. Furthermore, we considered the stepping, some variables from a stepping task, which was the step width and the step velocity, for example. We just found the significant difference in a step width within close and far distance, in which in the close distance participants, they step larger compared to far distance. And this larger deep step in close and far distance, it was just present in negative and neutral sounds. Concludingly, the premotor reaction times were shorter while reacting to neutral sounds compared in either in far and close distance. Since we use noises as the neutral sound, we think it's because of the large frequency spectrum that the signal had, and also since they were not carrying any semantical content. Another thing that we found was the premotor reaction time was shorter in negative sounds compared to positive ones. Also, it was visible in the far distance. And of course, this result was coming from negative events required more prompt reaction. And of course, we need to be more prepared to react to them. And in the end, we stepped larger while reacting to negative sounds and neutral sounds, which we think it is in line with the distance regulation hypothesis that we want to increase the distance from the negative and threat outside of us. Thank you so much for your attention. And my poster is number 51 if you want to check further. Thank you.